Hello students, welcome to the subject of complex variable and partial differential equation. Myself Dr. Ankit Acharya, and in today's lecture we will discuss about our case 5 to find particular integral in partial differential equation. So this is my case 5 called general method. Okay, that means f of xy is any function, you can apply this method. So first of all you have f of d dash, right? And from f of d dash you can factorize that f of d dash in a linear form, right? And after that, one by one, that linear factor that you have to operate on f of xy, how you can operate? For that you have to follow this rule. So let's see, 1 upon d minus m d dash, right? This is just a one linear factor, okay, on f of xy. How you have to operate? That is equal to, just try to understand the right side part, integration f of x is as it is, right? But instead of y we have to write c minus mx. That means what? Y is replaced by c minus mx. Let me give you one or two example. Suppose your function is like 1 upon d plus d dash on f of xy, okay, on f of xy. So in that case, what is your integration? Integration f of x. Now instead of y we have to take c minus mx. So just for your understanding, instead of d just you have to take c, and instead of d dash just you have to take x. So that means c plus x, okay, c plus x. Simple. I hope you all can understand. Now suppose 1 upon d minus 3d dash or something function, whatever your function f of xy, okay, then how you can operate? Integration f of x is as it is, right? But instead of y you have to write c minus 3x, right? C minus 3x, okay. So just try to understand this rule very carefully. I will use this case 5 in some of the example, because up to case 4 we already discussed what is your case 1. Let's take a quick revision. Case 1 is e raised to ax plus by. So to operate, to use case 1, definitely your function is in the form of e raised to ax plus by. For case 2, what is your function? Sin ax plus by or cos ax plus by. For case 3, your function must be a polynomial in the form of x raised to m into y raised to n. For case 4, must be your function in the form of ax plus by. So that means f of xy, that is equal to g of ax plus by. But suppose you cannot operate, you cannot apply from case 1 to case 4. So in that case definitely you have to operate, you have to apply case 5, because let's solve one more, let's solve example so you can understand. See, right hand side your function is y minus 1 into e raised to x. Now can you apply from case 1 to case 4 any case? No, you cannot apply, because this function is not a e raised to x plus by, is not a sine or cos function, is not a polynomial, it's not a function of ax plus by. So you cannot apply from case 1 to 4. So in that case, if you want to solve, if you want to find out the particular integral for this example, definitely you have to apply case 5. Okay, so I hope you can understand. Now first of all, as you all know that first of all we have to find complementary function. So what is my f of d dash? F of d dash, that is equal to d square minus d dash minus 2 d dash square, that is equal to 0, and the function of m, that is m square minus m minus 2, that is equal to 0. Factorization of this second degree polynomial, that we know m minus 2 into m plus 1. So what are the roots? Roots are 2 and minus 1. Okay, so complementary function, I can write complementary function, that is f1 y plus 2x plus f2 y minus x. Okay. Now I want to find particular integral, and for that, first of all, try to understand after integration c is replaced. So just also remind this, after integration, right, c is replaced by y plus mx once again. So first of all, we take y is equal to c minus mx. First of all, we take y is equal to c minus mx, and after integration, right, replace the value of c, that is equal to y plus mx. Okay, so please keep in mind. Now what is my particular integral? Particular integral that we know, 1 upon f of d dash. So 1 upon f of d dash, that is d square minus d dash minus 2 d dash square, and what is my function? Y minus 1 into e raised to x. So we can understand that roots are 2 and minus 1. So from these two roots we can easily factorize this function. Factorization is d minus 2d dash and d plus d dash. Okay, so we can write particular integral that is equal to 1 upon, because of roots are 2 and minus 1, so that's why I can write d minus 2d dash and d plus d dash. What is my function? Function is y minus 1 into e raised to x. Now one by one operate both the linear factor. So 1 upon d minus 2d dash, let's write here. So 1 upon d minus 2d dash as it is. Now I want to first operate d plus d dash. So that's why first of all we have to write, instead of y we have to write c plus x. Okay. So that's why this equal to integration c plus x minus 1 e raised to x dx. Okay. Now integration by parts. So 1 upon d minus 2d dash, that is as it is, integration by parts. So c plus x minus 1 as it is, integration of e raised to x, that is e raised to x minus differentiation of this function c plus x minus 1 with respect to x, so that is 1, and integration of e raised to x, so that is once again e raised to x, so we get e raised to x. So that's why when we simplify this function, 1 upon d minus 2d dash, this is c plus x minus e raised to x minus e raised to x. So we can write minus 2 e raised to x. So that's why this is something c plus x minus 2 into e raised to x. Okay, and now replace c plus x. Instead of c plus x, I can write y. So this is y. Okay, so y minus 2 into e raised to x. Now once again operate this function d minus 2d dash. So that's why for that we have to write, instead of y we have to write c minus 2x. Okay, we have to write c minus 2x. So that's why integration c minus 2x minus 2 e raised to x, and now once again integration by parts. So that's why c minus 2x minus 2 as it is, integration of e raised to x, that is e raised to x, minus differentiation of this function, that is minus 2, so minus minus plus 2. Okay, and integration of e raised to x, that is e raised to x. So this minus 2 e raised to x plus 2 e raised to x will be cancelled out. So finally we get c minus 2x. This equal to, I can write c minus 2x into e raised to x. But what is c minus 2x? C minus 2x is nothing but y. So I can write y into e raised to x. So this is my final answer for particular integral. And don't forget to write general solution. General solution is complementary function plus particular integral. Okay, let's solve one more example. So this is our next example once again. So f of d dash, function is y into cos x. So to solve this example also we have to operate our case 5. So first of all find complementary function. Complementary function f of d dash, that is d square plus d dash minus 6 d dash square, that is equal to 0. So this is m square plus m minus 6, that is equal to 0. So I can write m plus 3 into m minus 2, that is equal to 0. So roots are, I can say roots are minus 3 and 2. Okay, so complementary function I can write f1 y minus 3x plus f2 y plus 2x. Okay, now to write particular integral, I directly write factorization of this function. We know that f of d dash, that is d square plus d into d dash minus 6 d dash square, function is y into cos x. Okay, but when we convert this quadratic polynomial of f of d dash in a linear factor, so I can write, because minus 3 and 2 are roots, so I can write d plus 3d dash and d minus 2d dash. Okay, so this is d plus 3d dash and d minus 2d dash, right? And function is y into cos x. So I write this step once again. So this equal to 1 upon, let me write once again, d plus 3d dash and d minus 2d dash, and function is y into cos x. Okay, so first I operate d minus 2d dash on this function. So I can take y is equal to c minus 2x. Okay, y is equal to c minus 2x. So this equal to 1 upon d plus 3d dash as it is, integration. Instead of y, I have to take c minus 2x. So c minus 2x into cos x dx. Now integration by parts. So 1 upon d plus 3d dash. Okay, integration by parts. So c minus 2x as it is, c minus 2x as it is, right? Integration of cos x, so that is sin x, minus differentiation of c minus 2x, so that is minus 2, and integration of sin x, so that is minus cos x. Okay, and this equal to I can write c minus 2x replaced by y, so y sin x minus 2 cos x. So 1 upon d plus 3d dash, I can write y sin x minus 2 cos x. Okay, now I want to operate 1 upon d plus 3d dash, so that's why replace y by c. I write here on the next line. So replace y, that is equal to c plus 3x. Okay, replace y by c plus 3x. So that's why this equal to, let me write on the next page. So this equal to integration, instead of y, okay, I can write c plus 3x. So c plus 3x into sin x. So c plus 3x into sin x, and integration of cos x, that is sin x. So minus dx minus integration to cos x. Okay, integration to cos x dx, and we know that integration of cos x, that is sin x. Now integration by parts. First, for a first integration, so c plus 3x as it is, integration of sin x, so that is minus cos x, minus differentiation of c plus 3x, so that is 3, integration of minus cos x. Okay, so that is minus sin x, and minus 2, integration of cos x, so that is sin x. Okay, now replace c plus 3x by y. So this is minus y cos x. We can write minus y cos x. This is plus 3 sin x minus 2 sin x. So plus sin x. So this is the particular integral for this example, and don't forget to write general solution. That is z is equal to complementary function plus particular integral. Okay, so this is our case 5 general method. How to operate case 5, how to apply case 5. For that we discuss this two very important example. Okay, so to particular integral we already we discuss all our 5 cases from case 1 to case 5. So please, all the students, remember all the cases, very important. Thank you.